Our Tennessee State Standard today is to use informal arguments to establish facts about the angle sum and exterior angles of triangles, about the angles created when parallel lines are cut by a transversal, and the angle-angle criterion for similarity of triangles. For example, arrange 3 copies of the same triangle so that the sum of the 3 angles appears to form a line, and give an argument in terms of transversals why this is so. Your lesson objective that you need to write down: I can find missing measurements given parallel lines cut by a transversal and given one angle measurement. So pause the video and write that down. All right, so parallel lines are lines in a plane that never intersect. And on this illustration, your horizontal lines are your parallel lines. They're like railroad tracks. They'll keep going and never cross. A transversal is a line that intersects 2 parallel lines. And you can see the transversal is it's a diagonal line that cuts through both of those parallel lines. Interior angles lie inside the parallel lines. So inside, between the parallel lines, which means angle 3, angle 4, angle 5, and angle 6 are all interior angles. Exterior angles lie outside the parallel lines. So angle 1, angle 2, angle 7, and angle 8 are all exterior angles. They lie outside the parallel lines. Vertical angles are opposite. Now, we learned about vertical angles yesterday. So where the line intersects, they're straight across from each other. So 1 and 3, 2 and 4, 5 and 7, and 6 and 8. All of these are sets of vertical angles. And remember, vertical angles are congruent. They have the same measure. Alternate interior angles, well, we already know interior is inside, but alternate means they're on opposite sides of the transversal and inside the parallel lines. So 4 and 6 are alternate interior angles. 3 and 5 are alternate interior angles. Alternate exterior angles are on opposite sides of the transversal and outside the parallel lines. So outside the parallel lines and then on opposite sides of the transversal. So 1 and 7 are alternate exterior angles. 2 and 8 are alternate exterior angles. Corresponding angles are in the same position on the parallel lines in relation to the transversal. So angle 1 is above the line and to the left of the transversal. Angle 5 is above the line to the left of the transversal. So 1 and 5 are corresponding angles. 4 and 8, because both of those are below the line and to the left of the transversal. 2 and 6 are corresponding angles because both are above the line and to the right of the transversal. And 3 and 7 are corresponding angles because both are below the line and to the right of the transversal. If 2 parallel lines are cut by a transversal, then the following pairs of angles are congruent. Corresponding angles are congruent. So remember, they're in the exact same spot in relation to the transversal. So 1 is above the transversal to the left. So 1 and 5 are corresponding angles. 3 and 2 are corresponding angles. 7 and 8 are corresponding angles. And 4 and 6 are corresponding angles. And corresponding angles are congruent. So 1 is equal to 5. At the measure of angle 1 is equal to the measure of angle 5, and so forth. All right, then alternate interior angles are congruent. So alternate interior. So that means 4 and 5 are congruent. 3 and 8 are congruent. Alternate exterior angles are congruent, which means 6 and 1 are congruent, and 2 and 7 are congruent. So now you can see that, go back to my pen, angle 1 is equal to angle 4, which is equal to angle 5, which is equal to angle 6. So 1, 4, 5, and 6 are all have the same measure. Let's see, let's do the other one, that color. And then 2, 3, 7, and 8 all have the same measure. So when you have parallel lines cut by a transversal, you have 2 different measurements. It will be the measurement given, and since they form a straight angle, to find the other measurement, you would say 180 minus the measurement given. And then you can give angle measures to all the different angles. So it's either, the angle measure will either be the measure given or 180 minus the measure given. So let's try some. If angle 1 is 120 degrees, well, we only have 2, so 2 different angle measures. So we're going to say 180 degrees minus 120 degrees, and that gives us 60 degrees. The same angle measure will never be side by side. So, since this forms a straight angle, 2 would be 60. 3 would be 120. 4 would be 60. 5, 120. 6 would be 60. 7 would be 120. 8 would be 60. So it will either be the measure given or 180 minus the measure given. Let's try another one. Given angle 6 is 135. Okay, this is 135. So I know that every measure will be either 135 or 180 minus 135. 10 minus 5 is 5, 7 minus 3. So those are our 2 measures, 135 and 45. So if angle 6 is 135, angle 7 is 45. Angle 8 is 135. Angle 5 is 45. Angle 4 is 135. Angle 3 is 45. Angle 2 is 135. Angle 1 is 45. Ooh, a little bit different because our parallel lines are running vertically now, but given angle 5 is 45, so let me write that in here, that's small. Then I know my measures are 45 and 180 minus 45. So 10 minus 5 is 5, 7 minus 4 is 3. So it will either be 45 or 135. 45 is 5, so angle 2 is 135, angle 6 is 45, angle 8 is 135, angle 4 is 45, angle 7 is 135, angle 1 is 45, and angle 3 is 135. So you just, every other one. All right, what happens if you have two sets of parallel lines? You still are only going to have one measure, or two measures. So it will be the measure given and 180 minus the measure given. So 180 minus 50 is 130. So 50, 130, 50, 130, 50, 130, 50, 130, 50, 130, 50, 130, 50, 130, 50, and 130. Still only two measures. All right, last but not least, what if we have a set of parallel lines cut by two transversals? All right, so I know that angle B and 125 make a straight angle, so 180 minus 125, 10 minus 5 is 5, 7 minus 2 is 5. So I know angle B is 55 degrees. Angle C is equal to 45 because those two angles are alternate interior angles. And angle C and angle D make up a straight angle. So if we subtract angle C from 180, we will get angle D. So angle D is 135. Then we can get angle A because there are 180 degrees in a triangle. So we're going to say 45 plus 55 for angle B and angle C, which gives us 100. And then we're going to subtract 100 from 180 degrees that are in a triangle. So angle A would be 80 degrees. And then 45 degrees, 80 degrees, and angle E form this straight angle. So we can add 45 plus 80 to give us 125. And then we can subtract 125 from 180, that's in a straight angle, to find the measure of angle E. So 10 minus 5 is 5, 7 minus 2 is 5. So angle E is 55. This is a tough one. You won't see it much, but I just wanted to do one and show you how to find the measures. And yeah, you did need to write all that down, so you'll need to go back and write all that in your notes. And that's the end of our lesson video. I will see you tomorrow.